All right, we'll get started. We have a nice program for the last session, and Chris Callahan is our first speaker. He's going to be talking about post-harvest handling and how it can improve fresh market success with blueberries. So thanks a lot, Chris. He's from University of Vermont too, excuse me.
Everybody knows.
I can handle that part too, yeah. Thanks, Laura. Hi folks, Chris Callahan, UVM Extension. My role at UVM Extension is in ag engineering. And so a lot of my work has really focused on post-harvest handling and storage, primarily in vegetables, storage crops. But a lot of the practices that I've been looking at are really being primarily influenced by berry and fruit crops as well. So it's nice to sort of circle back and talk with a group of berry growers. I'm going to talk today about some project outputs that are coming out of a Northeast SARE funded research and education project that I'm doing jointly with Andrew Chamberlain, my agricultural engineering technician at UVM, and Robert Haddad at Cornell Cooperative Extension. And the project is really focused on pre-cooling and curing. So some dedicated practices and equipment for pre-cooling crops, as well as curing winter storage crops. And there's some similarities in the equipment and the practices between the two. So the bulk of today's conversation will be looking at pre-cooling as it relates to berry crops. And so one of the primary motivation for this work is remembering that what we're marketing is still alive. So fresh produce is alive, it's breathing, respiring, releasing heat, losing moisture. It can get sick and it can even die. And as berry growers, you probably all know what fuels this. What fuels respiratory metabolism? Heat. It's certainly dependent on heat. What is the fuel? Sugar. You're sugar peddlers, right? So we want to maintain as much of that as we can in the product. So respiration rate is something we really want to work to control. I'm sorry, I'm right in your way. How's that? There. And remembering that post-harvest is a hotel, not a hospital. So, sick berries are not going to miraculously be healed in storage. Maybe that's another research project we can work on, but generally speaking, all the science points away from it. So here's respiration. It's driven by temperature, as somebody said. The rate of respiration is driven by temperature. Hard to get that down to zero and still have a saleable fresh product. So you can get it to zero if you freeze it. But ultimately, you're going to have this chemical reaction happening that is, at the heart, converting sugar and oxygen to water vapor, carbon dioxide, and heat. And that's just going to happen. And so what do we do about that? If it's driven by temperature, and we really want to minimize how much of this happens, what can we do? Cool it. Yeah. Drop the temperature. And so here's an example of raspberries. Respiration rate is the black triangles. Temperature is our horizontal axis. And so you can see just how sensitive respiration rate is to temperature, and then the inverse relationship between respiration rate and shelf life. So the better job we do depressing respiration rate quickly, the longer our shelf life. And this is a couple of graphs from a paper that really sort of drove it home for me. This was the two data sets are wrapped using PVC wraps around clamshells, and this is unwrapped. And what they looked at is imposing a delay in cooling, a delay before cooling between harvest and when the product is cooled. And they looked at all these post-harvest quality parameters, weight loss from the product on the left, firmness of the product. This is color. On the left-hand side is it getting darker, product getting darker. This is strawberries specifically, so a darker strawberry over time and losing red color. So they're measuring the quality characteristics based on a delay in cooling and also this wrapping or not being wrapped. This is soluble solid content and fructose and glucose. And so what's interesting on especially the wrapped ones is that there's actually a slight bump in certain sugars with a delay in cooling. It's not explained by the researchers. Maybe somebody here knows what's going on there. Does this jive with anybody's experiences? I don't think so. So I'm not exactly sure what's going on there. The point is that soluble solids definitely declines with the greater delay in cooling. When we look at pre-cooling methods, what can we do to bring the temperature of the product down? There's certainly room cooling. I guess by show of hands, let me go through the methods first, and then we can do a show of hands. Room cooling, the idea that you have a walk-in cooler or a CoolBot or some cold room, and you bring packed product into it and let it come down in temperature. Forced air cooling is essentially that plus some really intentional airflow through the product to bring it down in temperature. Hydrocooling, top icing, and vacuum cooling are probably less compatible with berry crops. So show of hands, how many folks are doing some sort of pre-cooling? So let's say room cooling. You have a walk-in cooler, you harvest, you pack, and it goes in a walk-in cooler. What about forced air cooling? And what's everybody else doing? Direct to market? Okay. No cooling. All right. So one of the things that I learned about that I felt really could have some good applicability in Northeast crops, berry crops and other crops, was this idea of some intentional pre-cooling. And it's very common practice in higher volume production areas to have these forced air pre-cooling tunnels where there are two lines of pallets. These happen to be grapes in trays on pallets. They load them up against a wall, and there's a suction fan right there. And this curtain is on pulleys, and it comes down over those two pallets to create a little suction tunnel, as shown on the photo on the right-hand side. And so with the fan pulling air through that tunnel, it pulls air through the side of the pallets. And this is in a refrigerated space, so that's all cool air. And so you're really intentionally getting cold air over the product. It goes into the wall. That warmed air now goes into the wall. There's oftentimes an evaporator in there to cool that air again, and then it gets rejected back out into the room to go through the cycle again. And so this interested me as an engineer. The scale of it was beyond what I thought most of the folks I work with could really utilize, and so I thought about, well, how could we apply this practice in a more reasonable size or more applicable size. This is that same sort of thing in a slightly different style, and also with the pallets removed. So the pallets would go here and here, just to give you an idea that there's some sort of seal here. It's pulling air through. It goes through an evaporator and then comes out into the cold room. And so if we think about the principles at work here, instead of just looking at the specific practice, we've got refrigerated cold room, so this is an evaporator making cold air. And if we just load a pallet into that room or a container into that room, the air is sort of bouncing off the walls and there's nothing really forcing it through the product. So we're depending on really conduction of heat from berry to carton wall to air. And so that's a very slow way of getting heat out of the product. And so what the forced air cooling systems are doing is actually pulling this cold air intentionally through the product using some sort of curtain. So we thought about how to do this in a smaller scale. This is an example of a single pallet forced air cooler. And so we built a demo unit to do this. So using a pallet, we have some, in this case, some 1 1/9 wax box cartons on it. It could be berry trays. You really could adapt this to whatever your containers are. And we use some greenhouse poly to seal off 3 sides. The top, one side, and then the other side. The back, that's out of view here, is open. And the front is butted up against this plenum that we just built out of some 2x12 lumber and plywood. And then we put a suction blower on it to pull the air. So first, one thing this does is it makes a nice seal. So this film gets sucked right in against the boxes. It's really pretty neat to see. And then we open up the back. And so what we've done now is we've created a very intentional flow of air through the pallet in one direction. The idea is this could sit in a cold room. So now you haven't really added a whole lot of infrastructure, but you've got some very intentional pre-cooling in a walk-in cooler. Not just for berries, if you're doing other crops, could work just as well. So using an existing cold room, pretty simple construction, forced air cooler. One of the key things is this really needs to be a blower, different from like a greenhouse fan. So a greenhouse fan moves a ton of air at a low pressure differential. So it can move a ton of air as long as it doesn't have to move it through a lot of something. What we're trying to do is move a fair bit of air through essentially a HEPA filter, right? The air has to work its way through that product, and so you need a blower as opposed to a fan, and these are the specifications of this blower. It does 2,500 cubic feet per minute at about 2 inches of water column, and that is about right for that size. But you need. The key point is a greenhouse fan is usually a fraction of an inch of pressure rise, and this is integers of inches of water column. A compressor is hundreds or tens of inches. So that would be for a single pallet. Then we thought, well, even smaller. What if there's a single carton that somebody wants to pre-cool, and so we decided to put together a prototype using a CoolBot to provide the air conditioning. Folks familiar with CoolBots? Show of hands. So using a window air conditioner, tricking it to think that it's still above the temperature it's supposed to be, and so it just runs and runs and runs until the temperature gets down to a new thermostat level that's been introduced. So it's same essential hardware is inside a window air conditioner as is a walk-in cooler, a split refrigeration system. So the idea here is, something that maybe could do 4 1 1/9 bushel waxed cartons, or in this case 3 bulb crates. Could do this for a couple of trays, a couple of berry trays as well, just a slightly different box. The CoolBot is providing the refrigeration of the air. Then there is a suction fan in this little false wall here that would have a seal against the cartons, and so that would be bringing the refrigerated air through the cartons. So this one has been built. We're able to run it successfully. We have yet to actually do a tracked temperature profile with it with product in a cooler, but it's a very common practice elsewhere in a slightly different scale, so we expect very good results from it. This one we haven't quite gotten to the point of running yet, but also has the same basic capability. So. The other part of all this that is important is measuring those conditions. If the goal here is to bring the product down in temperature as quickly as possible before going into holding, it's best to make sure we're doing that. So could very easily look at a thermostat and say, I've maintained the temperature, but really what we've done is maintain the temperature of the room And so, a $30 calibratable handheld instant read thermometer to check the core temperature of product could maybe help identify improved pre-cooling practices, keeping track of, you can also keep track of temperature with a USB data logger. So these are really just like a USB memory stick that's also measuring temperature. And so you could put that in a Ziploc bag in whatever your harvest and storage containers are, and actually see what your product is experiencing going through your post-harvest process. So we also have an active project working on this topic, and we are looking for partners to demonstrate these systems or other systems that you might have in mind. If you have interest in improving pre-cooling or post-harvest storage of your crops, we'd love to chat with you and see if there's a way for us to get you a demo unit. Yes, sir. Yep. So the point I think is, why is it a suction system? Why not blow air through the pallets? My understanding is that it has to do with, if you think about having a fan right here blowing out, you're gonna, it's the pressure profile along that tunnel is exaggerated, versus if you're pulling air from a large room, that large room has a much more stable pressure. And so you end up with a much more uniform flow through each pallet. That's the idea behind it. Every pre-cooling, forced air pre-cooling tunnel that I've seen is a suction system, and that's my understanding for why. If you had a blower right there, these would get bypassed. You'd have a low section of low pressure there as it comes out of that entrance. And then somewhere along the middle, they'd have really high pressure and high flow. And then toward the end, they'd have low pressure and low flow. So it's trying to equalize that pressure differential. So you would have more pressure in certain areas, but it's about having an equalized pressure, is my understanding. Yep, so the question was about a blast chiller, like in a commercial kitchen, and getting a higher delta T, so between the product and the cold air. I haven't really looked at that. One of the things that I'd be concerned about is chilling injury. So it's possible to have too high a delta T, and so it is a balance. I think having some delta T is important, but I think it's possible to go too far and then maybe end up with splitting and things like that, because the surface changes temperature at a different rate or something. So it's a good thought. Other thoughts? I'd also be interested to know if anybody is willing to share what kinds of systems you're using and describe it a little bit.
Anecdotally, from a previous life, we tried to freeze chicken to ship overseas and freeze bread to ship overseas. And we used actually fans versus induction blowers. And what we did is very large ones, 4 feet high, 4 feet wide, and we loose stacked the cases. So we loose stacked the cases from what was a 5-block to a 4-block of the cases on the pallet, so that a lot of air could flow through those, so that you didn't get that flywheel effect of the mass of the product together. And it used to take us 3 days to freeze that product, and it got down to exactly about 22 hours to freeze that product solid all the way through when we tested it, because we were shipping to the U.S. military overseas and they wanted that stuff frozen fairly quickly. So I think fans can work if you have enough space for the air to flow by. I'm actually going to do exactly what you said. I've built a little refrigerated box that I'm going to put a blower on and suck the air through. And I'm going to have my berries on I don't know if you've ever seen bread proofing trays. I'm going to have bread proofing trays that kind of go into there and then hold the air through that, because I think your design is actually better for this application.
Thank you, Frank. Other thoughts? Other ideas people have thought of and either tried?
Tried and failed?
Yeah. Sounds like you got something to share. Right, and so the thing with condensation is once you get it down
Right.
to temperature, you need to keep it at that temperature. Condensation is going to tend to happen when you fluctuate, right? Yeah. So,
Yeah, that would be the one.
yep. Laura, anything you wanted to add to this?
Actually, I would like to ask people if anybody used those modified atmosphere packages?
Oh, yeah, that'd be good.
Those bags that they sell, some of them are giant, you can fit a whole pallet in, and some of them are small. Has anybody played around with them? We did a little very haphazard test actually a year ago with blueberries, which was probably because blueberries hold really well. We didn't see quite the difference, but we definitely saw a difference. And they're kind of an interesting package. We'd like to play around with them more. It's an interesting concept if you wanted to get just a little bit more shelf life. All of these were with situations that had really good coolers, but we actually did see slight, maybe 10 or 12 days, and I think we probably could have got more life out of them, but that's what we looked at.
With a blower?
Just throwing that out there.
I understand. With a blower or without a blower?
No, they're just
Just doing the pallet
envelopes.
wrap? The big,
Just
And we
packaging.
had small ones.
Oh,
They were
small packages.
They were literally just for one flat.
oh,
But they come in variable sizes. MAP, yeah. A lot of trade shows, there'll be people that are selling them, and we just thought, wow, this seems too good to be true, and it was pretty cool, actually. Right.
I was actually just impressed with the benefit of just simple PVC wrapping in this case. So these are wrapped, these are unwrapped for solid content, but also weight loss. The benefit of weight loss was really remarkable. So again, I think just trying to get the temperature down, and once it's down, basically wrap things up. Any other thoughts? Questions?
Thank you very much.
Thanks, folks.
Chris.
Yeah.